Hi, and welcome to 2.1 Distance and Displacement. In this lesson, students will be able to describe the difference between and calculate distance and displacement. So, we're actually starting talking about physics concepts right now, and we're entering the unit of mechanics, which is the study of motion. And if that seems very broad and general, it is. It's going to last until holiday break. So, we'll be in this big unit of mechanics until January. We're going to start with kinematics, which is a subsection of mechanics. So in the kinematics unit, we're going to study motion without considering its mass or external forces. This topic starts with distance and displacement. Then we talk about speed and velocity. Then we talk about acceleration. But we're not going to mention mass or any forces that might be acting on these objects. We're just kind of measuring how fast they're moving and their rate of change of velocity. Then we'll start talking about statics and dynamics. They kind of go hand in hand because you are starting to talk about forces at that point. In statics, all the forces are balancing each other out and the objects are in equilibrium. In dynamics, the forces aren't balancing each other out and the object is accelerating. So we do talk about acceleration in kinematics, but in dynamics, we start saying, well, why is that object accelerating? What are the forces acting on it? How are they so unbalanced that it starts to accelerate? So it's the study of motion considering its mass and its external forces, because it's not just the forces on the thing that matter. You have to take into account the mass as well in Newton's second law. But before we talk about all that stuff, we'll start by talking about kinematics. So the first thing we talk about, as I said, is distance and displacement. So the example I always give in class, and I kind of dance around the room and like maybe jog around my desk, is well, if you're sitting at home on your couch and you decide, okay, I want to go for a run, let me get up from the couch, go for a 2 mile run, and then I come back and collapse on the couch. Okay. The question is, how far did you go? Now, some people might say, well, I went for a 2 mile jog. I went 2 miles, right? I get credit for doing that. I'm exhausted right now. I definitely went 2 miles. That's how far I went. But you could also look at it, well, I started on the couch and I actually ended up right where I started on the couch. So how far did I go? I didn't go anywhere. So both ideas are totally acceptable and they're right. So we need a better way to describe how far something goes. We need to be more precise in our language that we're using, and that's where distance and displacement come into play. So distance is a scalar quantity. It's a quantity that refers to how much ground an object has covered during its motion. So in the example I just gave, the distance that you traveled is 2 miles. You went for that 2 mile jog. Displacement is a quantity that refers to how far out of place an object is. It is the object's overall change in position, and it's a vector quantity. So in that example, our displacement was 0 miles. We didn't go anywhere. We had zero displacement because we started on the couch, we ended on the couch. It says how far out of place it is. Well, it's not far out of place at all. If we started on the couch and ran 2 miles straight away, and then ended somewhere 2 miles away, our displacement would be equal to our distance. It would be 2 miles. The difference is displacement is a vector, and vectors have magnitude and direction. So every time you're describing a displacement, you need to also specify the direction. The exception to that is if you don't go anywhere, like in our example, we would just say 0 miles. And you can't really say 0 miles north or south or east or west. So it's acceptable to say 0 miles. Otherwise, you have to say like 2 miles north or 2 miles east when describing the displacement. And then just like we've been saying in Unit 1 when we were talking about vectors, displacement is measured from start to finish. So displacement is going to be our resultant vector when we take into account all the different motions that we do on our trip. So in the do now, I had you start at the White Plains Mall and then end up at the White Plains Diner. It's like try to find the shortest walking path between those two positions. And you could walk along these roads here. Is that your distance or your displacement, that blue dotted line? Well, if you just look at where you started and then you look at where you finished, can we draw just like we did in Unit 1 from start to finish? Let's draw our displacement vector. Looks like that, okay? So the blue is your distance that you traveled. You get credit for walking that 11 miles, or sorry, 0.6 miles it says, 11 minutes or 12 minutes. The displacement is measured from start to finish, and the expression is as the crow flies. Have you ever heard that? If you were a bird instead of a person walking on the streets, as the crow flies, it says how far out of place are you from start to finish. So you can measure that magnitude and say, oh, I went that far in that direction. Now, which one has a greater magnitude? The distance that you traveled or the displacement? Which one has a greater size, a greater magnitude? Do you have an idea? Well, the distance that you travel has a greater magnitude than your displacement. And if you think about it, your distance is always going to be either equal to your displacement or greater than your displacement. The distance that you travel can never be less than your displacement. For example, you start at point A and walk 3 meters east. The question is, what is the total distance you traveled? And what is your displacement? So your total distance is simply 3 meters. You've only walked 3 meters. But you have to be careful when naming your displacement because it is a vector quantity. You need the magnitude, which is 3 meters, the size of the vector, plus your direction. So we went 3 meters east. Nothing crazy so far. Then we're going to walk 4 meters south. And we're going to ask the same question. What is the total distance that you traveled and what is your displacement? So pause the video here and try to think about it. So the total distance is 3 plus 4. You get credit for all the distance that you walked, regardless of the direction. You just add up the total distance. So it's 7 meters is the total distance. The total displacement is always measured from start to finish. And then you could even draw in your displacement vector, and it should look familiar to some problems that we've been doing in the past. So the question is, what is the magnitude and what is the direction? Hopefully you can see that this is a 3, 4, 5 right triangle. So the magnitude of the displacement is 5 meters. But again, it's not just enough to give the magnitude when naming a vector such as displacement. You need to also include the direction, and we'll do that by doing the inverse tangent, which gives you an angle of 53 degrees. And in this case, this is east, we're going 53 degrees south of east. Okay, let's continue our trip. Now we're going to go 3 meters west. Okay, so what is the total distance that you traveled? It's 3 plus 4 plus 3, so 10 meters. And what is your total displacement? Pause the video, think about it. You're measuring it from start to finish. Your displacement vector now looks like this. All right, so try to figure out what's the magnitude and direction of that displacement vector. Well, the 3 meters east cancels out with the 3 meters west, so you're not going anywhere in the x direction, but you are going 4 meters south. And since those two 3-meter vectors cancel each other out, that's kind of what we're left with, 4 meters in the southern direction. And now we're ready for the final leg of our trip. We're going to go 4 meters north. So if I go 4 meters north now, try to figure out what's the total distance that I traveled. What's the total distance? For distance, you don't care about the direction of these vectors. All you care about is how far you walked. 3 plus 4 plus 3 plus 4 gives you 14 meters. But how far was your displacement? What is the magnitude and direction of your displacement? Well, I started at A and I ended up at A. So the magnitude of my displacement is 0 meters And I can't even name a direction because I didn't go anywhere when I look at my displacement. So that's fine for naming a vector. If the magnitude is 0, you don't have to say a direction. And that's about it. Thanks for watching. Have a great day.